This video looks at the role the highways play in the economic development of countries and the key design principles of highways. To help put these elements in context, you will look at the example of a busy intersection in Leeds, UK, and the challenges it presents to transport professionals.
This is the Lawnswood Junction, where the A660 meets the A6120 Outer Ring Road. It is one of the busiest junctions in the outskirts of Leeds, with over 60,000 vehicles passing through it each day. As a result, there is considerable congestion at peak times. According to Leeds City Council's consultation website, buses are often delayed at peak times, with delays worsened by Leeds-bound traffic queuing back to the roundabout from Headingley. Current facilities for pedestrians and cyclists are poor, with a high number of cycle collisions in recent years. The council are consulting on plans to reduce congestion at the junction by creating a new traffic light controlled 6-lane crossroads. The plans will include cycle lanes and footpaths to improve safety and offer healthier alternatives to travel in private cars. However, local residents fear the proposed scheme will make congestion worse rather than improve it, and that it will increase noise and air pollution in the area. Every highways project must consider how it will address each of the three key principles of highway design: safety, cost, and the environment. It must consider how it will balance the competing needs of each. Highways are very important to a country's economic development. The construction of high-quality road networks can directly increase a country's output by reducing transport time and cost, making a country or region more economically attractive. However, these road networks need to be safe for all users, not just private and commercial transport. They should consider the effects that they have on the environment, including noise levels, pollution, and visual appearance. They also need to offer value for money, both to their users and those who pay for their construction, for example, taxpayers. A basic requirement for safety is that drivers will be able to stop quickly enough if they see an object in their path. To provide the stopping sight distance throughout the entire length of the highway, designers need to consider the reaction time of the driver, the speed of travel, and the interface between the road and the vehicle's tyres. Such provision can be expensive, and the design speed for certain stretches of the road is often reduced to ensure that the stopping sight distance is attained. Construction of a highway involves significant amounts of groundwork and movement of lorries. A key principle of highway design is to minimise the quantity of materials that need to be imported or disposed of from the site. The geometry of the land plays a role in the cost of a highway. In mountainous areas, sometimes the enabling structures, such as high-rise bridges and tunnels, dictate the overall costs of the project. In recent years, whole-life costing, which considers not only design and construction, but the life cycle maintenance needs, has become the norm for evaluating project costs. Highways are built to connect places. The construction activities and subsequent traffic movements have significant impacts on the land they are built on and the surrounding environment. Biodiversity along the route will be disrupted. For example, forest inhabitants may have to be relocated because of the land use changes. The highway must also align with the existing landscape. Occasionally, there are heritage sites or protected areas that highways need to avoid, or take all possible measures to reduce their impact. In the UK, the Design Manual for Roads and Bridges, Volume 11, provides detailed guidance on protecting the environment and evaluating the feasibility of road schemes. Besides these three key principles of safety, cost, and environment, transport professionals also need to consider the following: demand for transport, geometry, drainage, retaining walls and other structures like bridges, pavement and accessories, and topography and weather. After being designed and constructed, road networks still require careful monitoring and analysis by transport professionals. As the Lawnswood example demonstrates, change to transport use over time can have a significant impact on a junction's intended performance. In this case, the increasing use of private cars and development of housing in the area has resulted in congestion. The increased volume of traffic significantly affects the efficient functioning of the roundabout, particularly at peak times.
So, the redesign of the Lawnswood roundabout presents a new challenge for transport professionals in Leeds. To meet it, they will seek to balance the competing priorities of the existing infrastructure: safety, cost, and the environment.